Hi, everyone. Welcome to week 5 of Introduction to Statistics, Unit 1, where we are going to look at lessons 1.8 and 1.9. In 1.8, we first look at how to determine if data is an outlier. Outliers may seem easy to notice, but in all actuality, we have formulas to determine if something is an outlier or not. Here you can see the formulas. Low outlier is less than Q1 minus 1.5 times IQR, and a high outlier is greater than Q3 plus 1.5 times IQR. Outliers are important to identify for three reasons. First of all, the data may be incorrect and a data point may actually not be an outlier. Second of all, they may represent a unique situation. And third, outliers really heavily influence the mean, range, or standard deviation. In 1.8, we also look at creating a box plot. Here we look at the first 4 steps for creating a box plot. First, you find the 5-number summary of your data. Second, you draw and label your axis with a horizontal axis and a quantitative variable underneath. Third, you scale the axis, beginning with the smallest values, and you set equal tick marks up through the highest value. Fourth, you draw a box that spans from the first quartile to the third quartile. The fifth step is to label the median with a vertical line, as you can see here. The sixth step is to identify outliers. And then the seventh step is you connect your box to the maximum and minimum values that aren't outliers. Here in this example, you notice that outliers are shown by asterisk marks, and this demonstrates connecting minimum to maximum Q1, Q3 with your median. In 1.9, we look at two different ways to describe the location of a data point within a distribution: percentile and standardized z-score. We're going to look at each of these through a real-world example. The example is that we have 25 statistics test scores that are given on the first test. Jenny scored an 86, and you can see her 86 here and her 86 here. To determine the percentile, you first order the scores from smallest to largest. In this case, there were 21 out of 25 scores that were lower than Jenny's score. To calculate the percentile, we divide 21, position of Jenny's test score, by 25, the total number of tests, and we get 0.84, which as a percentage is 84%. To calculate Jenny's z-score, the z-score is the score minus the mean divided by the standard deviation. So for this situation, we need to give you a little bit more information. So we're going to tell you that the mean score was 80 and the standard deviation was 6.07. And then we can plug in the values. Z equals value minus mean, 86 minus 80, divided by standard deviation of 6.07. That leads us to 0.99. This means that Jenny's test score is 0.99 standard deviations above the mean. When the z-score is positive, that means it's above the mean. When the z-score is negative, that means it's below the mean. Thank you for watching this video. We hope that it helped you better understand the concepts that were included in week 5 of Introduction to Statistics.